Good morning, everyone. How you guys doing? Hope everyone had a lovely 3-day weekend. 3-day weekend. Um, this is yours truly, and today we're going to be talking about arithmetic series. Now, we already talked about this kind of a little bit a couple days ago when I kind of just introduced you to what a series was and how a series is different than a sequence. So today I just kind of want to talk about that video that we just saw, or hopefully just saw. If you didn't watch that video, please click on the video and watch it. It's going to make a lot more sense about what I'm referring to. It's only 3 minutes and it's pretty clever. Even though it's in German, I'm sure you can figure out with the premise of it. So what I want to do is I want to talk about that video and just kind of talk about the general formula that they give you for arithmetic series. And then I want to do a couple of practice problems with you guys. So in the video, the teacher was asking the students to find the sum of all the numbers. So 1 plus 2 plus 3 plus, and all the way up to 100. So, and one of the students in this class found a clever way to have a shortcut. And the kids saw that, like, well, if you add the first number and the last number, you get 101. If you add the second number and the second to last number, you get 101. If you add the third number and the third to last number, you get 101. So if there's 100 numbers, in other words, n is 100. So there's 100 numbers in this pattern, okay? And where a sub n is also the same value as n. So if there's 100 numbers in this series, okay, and I know that 50 of these 50 pairs are going to equal to 101. So we know there's going to be 50 pairs of 101 sums, which gave us 5,050. Okay, so that's what the kid found, and the teacher, got upset with how fast the student found it, and decided to spank him a little bit. That was kind of an intense teacher moment. So anyway, but the whole point of this video is to kind of bring up the idea of how to find the formula, a general formula, which is in the book, and this is called the formula to find an arithmetic, to evaluate an arithmetic series. Okay, so if you take the number of numbers that there are in a pattern, so in other words, in this case we had 100, we're just going to call that n, and if you divide that by 2, which is how we got 50, right? So because there were 50 pairs of 101 sums. And, how do we get 101? Well, in this example, the first thing we did was we added the first number to the last number, right? So if you take a sub 1 and add it to a sub n, whatever the sum of this is, there should be n over 2 sums equivalent to that. So this is the formula. This is where they get it. Okay. Now this is the same thing. Oh, and by the way, this would equal s sub n. And this, again, this is only for arithmetic series, only for linear series, or linear patterns. So you can also just really, if you wanted to, you can also just write this in sigma notation. So sigma notation and this formula are essentially the exact same thing, except this formula over here only works for arithmetic series. In sigma notation, you can put anything that you want in sigma notation. It doesn't have to be linear, it doesn't have to be exponential, it could be quadratic. You can plug whatever you want in there. But the thing with the arithmetic series formula is it kind of, if you know that a series is arithmetic, and it still takes you a minute to type it into your calculator in Sigma notation, then that's a very excellent benefit of having arithmetic series. You just add the first number and the last number and multiply it by n over 2. Okay? So let's do some practice. I'm only going to do the first couple with you. So here's another example. And unlike on the previous page, like the example they did in the German introduction, our common difference is not 1. So let's see. This is going up by, if I were to think of this as a sequence first, even though this is a series, this actually should say, consider the series, because we're adding. It's not separated by commas, but essentially doesn't matter. So let's see. Each one is going up by 7. So we know it's arithmetic. Okay. So the common difference is 7 and a sub 1 is 4. Then the equation for this would be a sub n equals the common difference, which is 7, times n minus 1 plus a sub 1. So there's your equation right there. Okay. To write it in Sigma notation, so what are we starting off with? N equals 1. The pattern starts off with 1. That's pretty obvious. And what are we going up to? Ooh, I don't know how many numbers are in this pattern. So let's see. I know if it's going to equal 151. So I'm trying to figure out what number is that 151 in the pattern. And you see how my explicit formula kind of makes that so much easier for us. Subtract 4 on both sides. We get 147 equals 7 and minus 7. I probably could have just divided by 7 on both sides. Add 7, we get 154 equals 7, and therefore n equals, and let's see, 2, I believe that's 22. Okay, so there are 22 numbers in this pattern. So again, you see how I found out how I use the explicit formula to find the number of numbers in the pattern. And then over here in this part, we're just putting in that part of the explicit formula. We don't usually have an equal sign in Sigma notation, except for this part that tells you what n starts off with. So 7n minus 1 plus 4. And I'm going to put this whole thing in parentheses just to show that we'd be finding the sum of the whole thing. Sure, you can obviously distribute that 7, combine like terms, and put that in, but it's good practice to write this to enclose everything in parentheses. So here we go. We found that, and now I can just plug this part into the calculator. And if you're not sure, you can watch the video from a few days ago on how to use the summation information. That was a great rhyme, I know. You can watch the video from a few days ago to get information on that. If you have an older version, which again, I'm not sure why you would, because you should get the TI-84 that Texas Instruments is giving. If you have an older version, you can look up how to do that on YouTube. There's some commas you have to use. So you can Google that or YouTube it and they'll show it to you. So now if you want, so again, for part B, you can either just plug this information in here into the calculator and get the answer. Or because we know it's arithmetic, let's see if this is going to be easier for us. So we're finding the sum of the 22 numbers because we found out that there were 22 numbers in this pattern. And so 22 over 2. So there's going to be 11 pairs, and take a sub 1, which was 4, and add it to a sub n, or a sub 22, which was 151. So again, just like the video, what this is saying is that there's going to be 11 pairs of numbers in this series that are going to add up to 155. Okay, So we're going to have 11 times 155. Okay, so I don't have a calculator now. I believe I can do this. And I'm doing this really quickly, guys, so please forgive me. I'm trying to... Is it that? I believe it's 1,705. Oh, I had a calculator right here. I was just trying to, just show. Whoa. This is what happens when showing off goes wrong. 1,705? Calculator what? All right. I'm still working on my circles, or ovals, but hey, you guys get the idea. Don't forget there's a quiz on this stuff tomorrow. Hope this video made sense. I can tell by the whopping number of views that I have on these videos that these are coming in handy. All right, so be well. Don't forget you have a quiz on this. Spread the word, spread the love. Go Kits, and I will see you tomorrow on Zoom. Deuces.